not gonna get any better than this. Okay, so, we need to balance this equation. And do you guys recognize what type of reaction this is? Well, we have a hydrocarbon that's interacting with oxygen, and we're making carbon dioxide and water. Do you recognize it? What is it?
Combustion.
Yay! It's a combustion reaction. Good job. Okay, so we need to balance it, and if we remember, hopefully combustion reactions are all about carbon, hydrogen, oxygen on both sides. And we'll balance those in that order. We have a whole bunch of carbon, even more hydrogen, and just a little bit of oxygen on the reactant side. And then we have 1, 2, 3 carbon, hydrogen, oxygen on the product side. All right, so where do we start? We're gonna start with the carbons. So what number should I write and where should I write it? You can talk now. Anybody have an idea? Nobody wants to be on camera?
The CO2.
All right, in front of the CO2, what number should I write here? I'm gonna disagree with 9. Here's what, I'll just do it. 18. So let's start with 18 because 18 times 1 is 18 carbons. Is gonna affect our oxygens too. 18 times 2 is 36. Plus this one, don't forget about this oxygen over here. I always put a smiley face. So I don't, whoops, not there. So I don't forget about him. 36 plus 1 is 37. Okay, odd numbers make me nervous, but whatever. So hydrogens, we have 38 on this side. What we're gonna do over here to get the right number of hydrogens over there, 19, yeah, I was trying to remember. 19 times 2 is 38. So if we put a 19 here, 19 times 2 gives us the 38 hydrogens that we need, but this is also going to affect our oxygens. So let me recount, go ahead, zip it. All right, I'm gonna recount the oxygens. So 18 times 2 is 38, right? Plus what's 19 times 1 is 19. Is that 55? 38 plus 19? No? I have it written down.
It's 57 now.
Yeah.
57?
Yeah.
Did I miscount something? Tell me. No, I did, yeah, this here. 36. Is that 55? Right? Did it? Let's double check. 18 times 2 is 36. 19 times 1 is 19. Do we got it right now?
Yes.
Okay, 36 plus 19 is 55. Okay, if I'm wrong, you tell me. All right, so now we're at a place where the carbons are balanced, the hydrogens are balanced, and the oxygens are severely messed up here because we have an odd number over there. So what we're gonna do is just pretend like we can put like a half of a number here so we can balance it. So what number times 2 gives us 55? 27.5. Okay, so that gives us the 55. Now, we can't have half of an oxygen. We have to have whole numbers here. So what's the solution to that?
You double everything.
We're gonna double everything. All right, so we're gonna put 2 here. We're gonna cross that out and put 55. Cross that out and put 36. Cross this out and put 38. Or you would erase it. I'm crossing it out so you can see the process. All right, so now what I'm gonna do is I'm gonna erase all of that and then just put the 2, 55, 36, 38 so that people can see what it looks like when it's balanced without all the scratch work. But before I do that, do you guys have any questions about how that got balanced? Okay, so let me erase it and put that in. So what did we say? 2, 55, 36, 38. So looking at the answer, that looks kind of crazy, like how did we get there? But it was actually the very straightforward process, except for remembering that you can temporarily put, you know, like a whole number 0.5 just to balance, And then to make them all whole numbers, you double everything across, like you're multiplying all the numbers times 2. Okay, we're ready to move on?
Yes, ma'am.
Okay. So let's get out of here and get to your worksheet again. Stoichiometry. All right, so while your candle is burning, or wherever we're at, third period is gonna be a little bit different for that. We're gonna go back to yesterday's. Okay, yeah, everybody can hear that. Bye, done. So yesterday you guys filled out this for the yeast lab, right? You took the yeast, you gave it sugar and water and a little bit of warmth, and you allowed it to grow, right? You took all of this data. So what do we need to do with this? The balanced reaction, we did that yesterday. Okay, then where did each of the reactants come from? If we're looking at the balanced equation, where'd it go? Above here. I was actually looking at that question. I was thinking, what are they trying to get you to say? Oh, so where is this reactant coming from? Like what is that? C12H22O11. That's just a series of letters and numbers. But what molecule is that? I'll give you a hint. It's in this list somewhere. And it's not the balance. What molecule is that? It's sugar. It was, yeah. One of those things, and it wasn't the balance. All right, and then what molecule is that?
Water.
Water. Okay. So when we're talking about, where did each of the reactants come from? That's what they're asking there. Right. The C. Now I forget. Is it C11 or C12? C12H22O11 is the sugar, and then the H2O is the water. And then where did each of the products go? All right. So looking back at the balanced equation again. CO2. Where did the CO2 go?
Into the atmosphere.
Into the atmosphere. It's a gas, right? And then this is ethanol. C2H5OH is ethanol. What happened to the ethanol? Did that go to the atmosphere or did it stay in the beaker? Those are the two things. What does AQ mean? It stayed in the beaker because AQ means aqueous, means it's part of the water solution, right? Aqueous relates to the word that like Latin or Spanish for water, right? All right, and then what chemical or chemicals does the change in mass represent? Did you guys find a change in mass? Did it weigh differently at the end than it did right before? Like when you added the yeast, compare that part there. When you added the yeast and you started the time, look at that number here. How does that compare to this number here? Got heavier? Okay, did anybody find it getting lighter? Yeah?
We did.
Okay. Yeah, that could be an issue. So you gotta consider that, right? So think about that. That'll be a different thought depending on who did what. And then we'll go more into, because I see we're almost out of time. We'll go more into tomorrow, like what happened there. Because one of those is gonna be right, one of those is not gonna be right. All right, but I wanna go through this first. How many grams of CO2 were produced during fermentation? Fermentation is just the chemical reaction that was happening. All right, so how many grams of CO2? Now if I start writing up here, I'm gonna have to go back and forth. This is what we don't know. Okay, how are we gonna figure that out? So there's two things we could do. If you had a lighter what do you call it, a lighter mass, then you would be saying that all the mass that was lost to CO2. You could use that as your grams. Otherwise, if you're thinking it's heavier, then all the mass went into the production of ethanol. And the ethanol's lighter than water though. But is it lighter than sugar? We'll figure it out. Let's do it theoretically. How many grams would you expect to produce? How would you figure that out? From the sugar. So let's say you guys put in 5 grams of sugar, right? I can't read it right now because I'm looking, oh actually I can. So you guys added 5 grams of sugar, am I right?
Yes, ma'am.
Okay, so if we're figuring we added 5 grams of sugar, how many grams of CO2 should we have made? How would you figure that out? Right, you write down first what you know, like you put 5 grams of sugar in because you were there, you did it. Then we need to do, what do you call it? Dimensional analysis conversions. Right, so I'm going to use this C12, H22, O11, and we're going to multiply. So we need to compare grams of C12, H22, O11. We're going to have to switch to talking about grams of CO2, so we have to do a mole-to-mole switch. So we got to switch this to talking about moles. C12, H22, O11. All right, so how are we going to figure out how many grams in 1 mole of sugar? I need more workspace. I'm gonna have to move to the whiteboard. Johanna, you gonna be able to follow me there?
Yep.
If you can see me from there, you don't have to move, but if you need to move to see me. All right, so C12, H22, O11. All right, you'd add up all the masses. What's 12 times 12? 144, right? Plus 22, plus whatever 16 times, I don't have my calculator now, whatever 16 times 11 is. Somebody do that for me? What's 16 times 11?
176.
176?
Yes, sir.
Okay. If anybody finds that to be wrong, let me know. And then if we add all these numbers together, can you guys do that? And this is going to be our molar mass.
343. 342.
342?
Yes, sir.
Okay, we all agree with that?
Yes, ma'am.
So that's the molar mass of sugar, unless somebody says that it's a different number. But that looks right to me. All right, so we're gonna use that, 342 grams. And now we can cross cancel. Life is so much better when we're doing stoichiometry. And we're gonna switch to moles of CO2. I think this is the last problem I'm gonna be able to do because we're running out of time. So now we have to look back at the balanced reaction, which I didn't write down, so you guys have to tell me. So in the balanced reaction, what's the number in front of CO2 and what's the number in front of C12, H22, O11? So looking back, which I didn't write that down for myself, you balance the reaction, what are the numbers there? I seriously need your help. Italy.
Oh, no, it's just
Moises.
For CO2, 36.
And you guys tell me if Moises is right or wrong. Is that right?
Yeah.
Was anybody else here yesterday? Yeah. Okay. The number in front of C12, H22, O11. Do you see it, Jasmine?
No, that's all I have.
You don't have it? From yesterday's warm-up? Didn't we balance this equation? Or not yesterday, but Monday, sorry? We balanced it together. Anybody write it down? Do I have to balance this again? Yeah. And then, remember I said it's this reaction here for the yeast? The warm-up was the answer to the balanced reaction.
It's 1144. So one in front of the carbon 12, and then another one in front of the H2, a 4 in front of the carbon and oxygen 2, and then a 4 on the end where carbon 2, hydrogen 5.
I remember that now. So there's only 4s after the arrow.
Yeah.
Okay, so there's a 4 in front of the CO2, and there's no number in front of the C12H22O11, so it'd be 1. Am I right about that? Okay, you guys gotta write this stuff down. All right, then we can cross cancel this here. Now this would tell us how many moles of CO2, but we want grams. All right, so now we need the molar mass of CO2, which is, what's 36 plus 12? 48, that sounds right. Am I right about that? Okay, 48 grams CO2. So I'm not gonna do the math because I can see we're running out of time, but now we can cross cancel that. And you can see if we do the math now, the only unit that's not crossed out is grams of CO2, which is where we want our answer. That's the kind of thing you need to do throughout here. Liters we haven't talked about, and so I'll talk about liters tomorrow. But anything with moles or grams, you guys should be able to do, at least be able to try it. Okay, so remember when you're going mole to mole, you're pulling numbers off the balanced equation. When you're going moles to grams, you're doing molar mass. You're looking on the periodic table for the weight of the atoms and adding the weight of all the atoms together. Okay, you can turn it off.